Hello. So hopefully my neighbor keeps his lawnmower off from this point going forward. But this lesson is about balanced and unbalanced forces. And in order to talk about that, we actually first need to do a little bit of work about understanding what is net force and how to calculate it. So that's what we're going to do in this video. So in your note packet, um, there are a couple things to be writing as we go along here. So let's start with what is a free body diagram, because that is what we're going to be using. It's just it's a model, right? It's a little diagram that we can use to sort of understand the forces on an object. So we tend to use, a box as our object. One, because it's super easy to draw. All you have to do is draw a rectangle, right? And then arrows to show forces. So free body diagram is a simple diagram that shows all the forces acting on a single object. Now, these obviously could get very complex. We're going to keep it really simple. We're going to have forces in one dimension only. So, as you know, the standard unit of force is a Newton. So on this box, we have a force of 3 newtons, and you can see that this is actually a pulling force. Oops, no. Need my pencil. This is a pull. Okay. I will get better with this pen. We're hoping. Anyway, that says pull. Um, Whereas I can draw another version of this diagram where there's still 3 newtons of force acting on this box, but the way that I've drawn it, this is a push force. So the outcome is the same, but depending on how you draw the arrows, the force is differently applied. All right, next slide. Net force. So what is a net force? Well, it's just the combination of all the forces acting on an object. It's the net. So let's do a couple examples of calculating it. So here is our friendly box, and you can see force 1 is a pull of 3 newtons to the right, and force 2 is a pull of 8 newtons to the right. So two forces pulling on this particular box. So net force, we need to combine them, right? We need to add them. So F1 plus F2. So let's write it out. F1 is 3 newtons plus F2 is 8 newtons. And that equals a total of 11 newtons. And the direction is important here, to the right. Okay, so let's look at another one. Okay, so now our box has a push force and a pull force, and you can see that they're acting in different directions. So the net force is still F1 plus F2, but in this case we need to be mindful of the directionality. So F1 is 5 newtons, so I'm going to write 5 newtons plus F2 is also 5 newtons, but it's negative because it's in the opposite direction. So I need to write that as a negative 5 newtons. So our net force is positive 5 plus negative 5, which is 0 newtons. Another situation similar to the last, except our F2 has increased in magnitude, still to the left. So again, F1 plus F2 is our net. So F1, 5 newtons, plus, remembering that this is a negative because it's in the opposite direction, negative 10 newtons. What is our net? Well, it is negative 5 newtons, which means that the net force is to the left. Okay, I thought I was doing better with this pen, but clearly I'm not quite there yet. Okay, so take a look at your note packet, make sure you have the definitions, and it also is going to ask you to draw two free body diagrams. Oh, wait a minute, did I? Nope, I missed a slide. There's another slide here somewhere. Here it is. Okay, so we talked about net force being 0, net force not being